Okay, so I am also going to show it algebraically. We found these using Desmos, which is a great tool, and I highly recommend it. It is probably the most efficient way to solve a system of equations, but if you happen to not have access to Desmos either on your phone or on a computer, we can also do it by hand, and in this case, we're going to use substitution. So because these are both equal to y, and they both have a y that's by itself, we can say, well, 3x equals y and x squared minus 4 equals y, so therefore they are equal to each other. So I can set them equal to each other. So I have 3x equals x squared minus 4. And so we have to, because this is a quadratic, because we have an x squared, what we need to do is either complete the square or use a quadratic formula or see where, or factor to try to see where this is going to equal, what x is going to equal when it's 0. So move the 3x over. I'm going to go ahead and swap sides. So I have x squared minus 3x. It's minus because we use the inverse operations, minus 4. I also have all three of these just because there was no like term. This has an x, sure, but the exponent is 2, so it is not a like term of the 3x. Okay, so the first thing that we can see if we can factor, if we can think of the factors of negative 4, that would be 1, negative 4, negative 1, 4, 2, negative 2, and negative 2, 2. So then if we add these together, I'm going to say p plus q. If we add these together, we'll see what we get negative 3, positive 3, we get 0, we get 0. So we're looking for a negative 3, so luckily it can be factored. We're going to have x minus 3. This is another reason to use Desmos. And then we have x. No, not minus 3. Oops. I went too fast. Okay, hold on. So what I meant to say was we have, oops, I don't know which one to pick. Green, that's fine. Okay. So I was looking at here, I need to look at here. So because this negative works, then numbers that we're putting inside the parentheses as we factor it are going to be x plus 1 and then x minus 4. And I don't know why this disappeared. That was strange. Okay. Then this is equal to 0. Now by our 0 product rule, we know that if this factor is equal to 0, then the whole thing is equal to 0. And if this is equal to 0, then the whole thing is equal to 0. So we're going to find both instances, and we should see over here in our solution set what those are going to be. So we have x equals x plus 1, equals 0. Using inverse operation, we're going to solve for x, and we get x equals negative 1. That's matching so far, so that matched with this one. Then the other one is going to be x minus 4 equals 0. Inverse operations again, so I'm adding because I started out with subtraction, and you have to do it to both sides to keep things equal. These cancel, so I get x equals 4. And again, that matches with what we got when we did it using Desmos. Now, in order to find the y value, we pick which one we want to use to plug in what we got for x. I always like to pick the path of least resistance, so I'm going to use the equation because we're just going to multiply by 3. So y equals 3x. So I'm going to say y equals, let's plug in 4. Y equals 3 times 4, and that equals 12. So that checks out. Then we have y equals 3 times negative 1, and that equals negative 3, and that checks out. So our solution set via algebra and substitution is the same as what we got when we graphed it. So really it's up to you, and it's also up to whatever sort of technology you have. We were able to factor, which was great. I assumed we were going to be able to because we didn't have any decimals or not nice numbers basically here. Anyway, so we just did it via graphing, and now this is via substitution.